Hi everyone, and welcome to our course From Basic to Brilliance, Mastering CST Antenna Design's Fundamentals. As in the previous lectures, we have learned about the CST Studio, and we designed different shapes in CST Studio, and we have learned about designing a patch antenna, about different slots in the patch antenna. We have learned about the S11 parameter, and again, in this lecture, I will teach you that how you can design an antenna with equations. So while designing an antenna with equations, we must know about the frequency. For example, if we are designing an antenna for 5 GHz, for 10 GHz, 15 or 20 GHz, from that frequency, we can calculate the dimension of the patch. That what should be the dimension of the patch for this desired frequency value. So let's go into the lecture. So we have a patch antenna. You can see this is a microstrip patch antenna, and this is the width and this is the length of this patch. And if we have to design this antenna for a certain frequency, we should follow some equations. From those equations, we can calculate the dimension of length and width. So if we have to calculate the width of this patch, we will follow this equation. And if we have to calculate the length of this patch, we will follow this equation. So here in these equations, the frequency of resonance is represented with F0, which is also called as resonant frequency or an operating frequency. W is the width of the patch. L is the length of the patch. H is the thickness of the dielectric substrate. And epsilon r is the relative permittivity of the dielectric substrate. These relative permittivity vary from substrate to substrate. For Roger, FR4 or any other dielectric material, we have different relative permittivity value. In this equation, we have another variable which is represented with c, and c is the speed of light, which is 3 into 10 raised to the power 8. So let's solve this equation step by step. In step 1, we will calculate the width of the patch. To calculate the width of the patch, we will follow this equation. In this equation, we should know about the operating frequency, which is F0, and we should know the relative permittivity of the dielectric. By using these values, we can easily find the width of the patch. In step 2, we will calculate the effective dielectric constant. This is based on height, dielectric constant of the and the calculated width of the patch antenna. So we will follow this expression for calculating the effective dielectric constant. We will put values within this equation to find the dielectric constant, which is an effective dielectric constant. In step 3, we will calculate the length of the patch. We will use this expression. We will put the effective dielectric, width, height, and the operating frequency to calculate this length of the patch. Here we have an example for designing a patch antenna. In this example, we have to design a patch antenna that is operating at 13 GHz. The substrate should be FR4 and the thickness of the dielectric should be 1.57 millimeter. So we will design an antenna which is operating at 13 GHz. The frequency could be any. It depends upon the user requirement. It could be 2.5 GHz, it could be 10, it could be 15 GHz or any value of frequency which is desired by the client. So in order to calculate this antenna, we will show you a picture in which we have the length and width of the patch given here. So first we will calculate the width of this patch antenna. Then we will calculate the length of this patch antenna. So we will follow some basic expressions. These are the basic expressions which we will follow. So the given value of the resonant frequency is 13 GHz, which is 13 into 10 raised to the power 9 Hz. The thickness of the dielectric substrate is 1.57 millimeter, which could be represented as 1.57 into 10 raised to power minus 3. Similarly, the relative permittivity of the dielectric substrate, which is FR4 in this case, which is represented with epsilon r, is 4.3, and the speed of light, as we know, is 3 into 10 power 8. So to calculate the width of this patch antenna, and then we will calculate the length of this patch antenna. So step 1, calculate the width of this patch antenna using this expression. C is 3 into 10 power 8, F naught is 3 into 10 raised to power 9, and epsilon r is 4.3. By substituting all these values within this expression, we get the width is equal to 7.14 millimeter, or 0.00714 meter. So we have calculated the width of the patch antenna, which will be substituted under expressions to calculate the length of the antenna. In step 2, we will calculate the effective dielectric constant, which is represented with epsilon r with subscript EFF. This is the expression. We have the epsilon r value 4.3 for the FR4. We have the height 1.57 millimeter or 0.00157. So, and we have calculated the width in the previous expression, which was 0.00714 meter. So we will substitute these parameters in this expression to calculate the effective dielectric. So after substituting all these values in this expression, we have calculated the effective dielectric value 3.10. So this is the effective dielectric value which we have calculated in this step 2 of the expression. In step 3, we will calculate the length of our patch antenna. We will follow this expression. In order to calculate the length, we will substitute the height, which is 0.00157 meter. This is the height of the dielectric. We will put the width, which is 0.00714 meter, and we will put the effective dielectric value, which is 3.10. We will substitute all these values in this expression, and we will get the value of the length, which is 5.1 millimeter or 0.0051 meter. So we have calculated the values of the width and length of the patch for our desired frequency. So this is the analytical approach for calculating the length and width of the patch. If we know the desired frequency and the dielectric, we can calculate the length and width of the patch. So if you have any question or any suggestion, you can send us an email or message. We will respond you quickly. So in this lecture, we calculated the antenna patch dimensions with the analytical expressions. In the next lecture, I will use these dimensions which we have calculated through these equations, and we will implement the patch antenna in the CST studio, and we will show you the results. Thank you so much.